Large quantities of warm water from the Atlantic Ocean flow northwards along the coast of Norway and onwards to the Arctic Ocean. This animation shows warm water in red and cold water in blue. In the north and west, sea ice is seen as a shaded blanket. Darker grey means thick, dense sea ice. Much of the warm water enters the Barents Sea and affects the climate and ecosystem there, while some travels northwards towards Svalbard along a second branch. Along the west coast of Svalbard, the current flows rapidly northwards. Some of the heat finds its way into the fjords and ensures ice-free conditions nearly all year round. As the current continues to travel north, part of the heat escapes to the atmosphere. The water is thus gradually cooled, and the air is quite warm considering how far north it is. In the Fram Strait, the area between Svalbard and Greenland, more heat escapes sideways, and the current splits up into several branches. Large rotating eddies are generated along the boundary of the current. They mix warm and cold water, and these eddies are an important mechanism for transporting warm water away from the main current. Part of the flow turns west in Fram Strait towards Greenland and flows south along the East Greenland shelf. The main current splits up even more when it approaches the Arctic Ocean proper. One part travels around a subsea plateau, where the current gradually slows down and a lot of heat is lost through mixing with adjacent Arctic water masses. Here, the warm Atlantic water sinks down under sea ice. A buoyant layer of fresh surface water partly protects the sea ice from the warm Atlantic water below. Another branch of Atlantic water follows the coastline quite closely and continues northeastwards along the continental slope north of Svalbard. This branch continues on a long round trip around the Arctic Ocean. It takes several years before it finds its way back to the Atlantic Ocean through Fram Strait. Along the northern coast of Svalbard, the warm inflow continues its journey into the Arctic Ocean. The heat is still near the surface and contributes to melting of the sea ice. In this region, large areas have been ice-free even in midwinter in recent years. This is primarily due to the increasing inflow of oceanic heat from the south. Part of the Svalbard Current branch flows into the northern Barents Sea, and this region has also seen reduced ice cover lately. The same tendency is seen north of Russia, with longer ice-free periods allowing for increased ship traffic. The oceans north of Norway are changing. The sea ice cover is shrinking and more temperate marine species are establishing themselves further north. At the same time, the area is characterized by large variability. Winters are still cold and dark, and there are large differences in ice cover and temperature between years. To better understand how the system works, both numerical simulation models and extensive field measurements are needed. The scientific programs of the Fram Center contribute to this, and we are working hard to better understand the contemporary climate system and make better prognosis for the future.